Hello, this is Kevin Sheehan, and today I'll be presenting my SAL 413 final project. And the data set that I chose was 2019 gambling data and some 2019 batting data from Sports Reference. And the purpose of this presentation and overall project is to find if there's any type of bet or other general betting trends that indicate that a certain type of bet is better to take over the course of a year, and what other correlations that we can derive and try to refine and figure out an edge in the general market of betting. And so I imported this data set right here, and that is my odds. So it gave me a final score, opponent score, open, run lines, but for the most part, we'll be using final score, opponent score, and the opening line, which is this. And if you're not familiar with gambling, the positive number is the underdog and the negative number is the favorite. And that'll come in handy when we do our calculations further down. And I already loaded this in just so it doesn't take any longer. But the new column that I've created in MLB was the MLB return and the MLB close return. But for the most part for this project, I just use MLB open return. So this was basically an if-else statement. So if you bet $100 on each position for each game throughout the course of the year, what return on money would you get? So if you bet the underdog, which is if it's higher than 0, that positive number, and their score is higher than the opponent's score, then you'll get that money back. But if you have the vice versa, you have the negative team, so the favorite, you get this calculation where it's 100 divided by the position times 100. So depending on the variance of if it's a low favorite or if it's high favorite, that number will always be either closer to 100 or lower. And then if you had neither of those, you get the negative 100. So that's assuming that you lost the bet. And we'll run that. And then what this code did was that it just reduced the decimal points to 2, and then this omitted any NAs in it so I can run further calculations. And what this code chunk did was it gave me a 1 or 0 based on if the team won or lost, which would prove helpful when I created this cumulative stat of their win record. So what I did was I created a data frame here and then another data frame here. So what the first data frame does is it gives me a running stat of the team throughout the year. So it's grouped by team. So this first team is Arizona, and it goes Baltimore, and so on and so on. But then you can see how the team improves or does worse. So in the beginning, Arizona, they lost their first game, and then they won their second, so they're 500. But then, as you see, they made it to their 35th game. They went up to 58, which is pretty good, but they ended the season around 500. But for data frame 2, this generalized it into each team for the whole season. So it doesn't give you each specific game, but what it did was it gave me wins for Arizona and every other team and loss for all that. And I produced a win percentage as well. And then what I was also able to do was produce the average money line that team had for each game over the course of the year. And then from there, you can calculate what Vegas, because Vegas produces this money line, what Vegas thinks that win percentage is over the entire year. And then from there, I was able to subtract win percentage from money line, or money line from win percentage, and see what the difference is. And that'll prove helpful in visualizing later on. So that's why I run right here. And then this bottom line of code where it just removes a certain row. There was a small miscellaneous game. I believe it was the All-Star game, but that was removed just to easier see over visually. And then from here I made my linear model. So what I weighed was that the average money line and the money line win percentage. So basically it was what Vegas predicted over what actually happened. So I'll run right now. It's already there, but just to prove that you can run. So basically you can see right here, it's a pretty well fitted line. So this kind of we could determine right here if we look at the summary of it as well. Vegas kind of knows what they're talking about. They have a pretty high R square, 96, which is very confident. So that shows that they're going to be accurate most of the time. But then what I also did was here, I selected or labeled only teams that had above 0% chance or 0 for difference. So only teams that if you bet on for every single game of the year would net you a profit. And naturally, of course, it's going to be less than half because if it's more than half, Vegas wouldn't be able to do what they do. But you can see that it's only losing teams. So in the bottom x-axis is predicted versus actual. So there are some teams that outperform. So San Francisco, you could see, outperformed. Texas outperformed. Some teams underperformed. Actually, no, sorry, none of these teams underperformed. All of them overperformed because they positive on difference. But as you can see, they're all losing teams below 500. So betting on the favorite isn't always the smartest thing. Sometimes it's smartest to bet on the underdog. But that's kind of a hard thing to do for any average bettor or any person to have that much trust over a whole season on such a losing team. And then also I combine the two data frames. So I combine the first data frame with each individual game and that running total onto MLB. And then as we go further down, I decided to import batting data from Baseball Reference. And so I'll run it one more time. So basically it had hitting data, hits, runs, all that stuff. So that is useful. And then what I had to do was, because the two data frames had different names for the teams, I switched it over to the Baseball Reference names, the ones that were different. And then what I did was I saved that data, saved it to my working directory, and I re-imported it back in and corrected it with certain numbers, and so making certain columns numeric, certain columns not numeric, just so that I wouldn't have any trouble later on. And I did that in the import dataset tab up here. The next column I did was I created bins. So this would help when I visualize the data. So I'll run that right now. So I got final data. And this basically just binned up what the money line was, or the win expectation for the money line. So basically what that is, that's the predicted tiers. So what Vegas predicts how each team will do, and each team within a bin. So if a team is expected to do really bad, it'll be in the 20s, 30s, 40s, 50s, so on, so on. And then I had what actually happened. So I believe I ran that, yeah. And then if we go further down, we'll go to the visualization section. So I already have them loaded, but I'll give one more run through. So we can look at the first table. So I have 6 tables here. Each one looks at the difference between, you can't see that, okay, just want to make sure you see it. The first table looks at the difference between the win percentage against the money line. So what actually happened versus what was expected. So, or what actually, how those teams were bin together. So the actual tier, so teams in their 30s were usually higher. Teams in their 40s were also dispensed, so some were favorites, some were actually higher. In the 50s, they're all favorites, and then we had 60s as well. And this NA, just for some editing purposes, it was Detroit, and they're in the 20s, but I included them as an NA. And then over here, we see the Vegas winning prediction against the money line. So this is what predicted was, and this is what actually was. So if we toggle between the two, you can see. But this is what the 30s, they're all predicted to be money line favorites, or money line underdogs, apologies. So were the 40s, so were the 50s, so were the 60s, so were the 70s. So this one's a little bit more regimented between the two. So 30s and 40s on the right side, 50s, 60s, 70s on the left-hand side. but to note there would be no team that received 70% wins. And then if you look over here, back to the first infographic, it's mixed between the two. So that's what actually occurred. And then when we go to our third graphic, it's the density of hits categorized by winning percentage range. So what actually happened, those teams categorized in those bins compared with the 2019 hits for each team. So as you can see, teams that were lower had higher density of less hits, but then teams that won more had a higher density of hits. And to note that there were much more losing teams in their 30s than winning teams. So that's why the density is a little different between the two. But it's a clear evident line that in order to win more games and be in those 50, 60 range, you need to get more hits. And then same thing, but with the predicted tier. So this was predicted is a little bit more even. So a little bit more progression of teams in lowers than 40s and 50s, 60s and 70s. But that's not actually what happened if we look back at that first graphic. It was a little bit more moshed. And then our last set of graphics, the winning percentage against expected winning percentage error. So basically this is what actually happened. So what actual bin area they're in, and then the difference expected. So when we look, or when we recall that first linear regression model, we saw that only lower teams had a higher difference, or a difference above zero, and that's true for teams in their 30s and 40s. So those teams were profitable over the course of the year, where teams that were winning, and even teams that are losing, this NA up here, lost, so you assume maybe they had a higher difference because Vegas judged them to be worse than they are, but they actually performed much worse. So they netted a negative. As well as teams that did really well in their 60s, 50 percentile or percent range. And then if we look at the expected, so the predicted winning percentage against expected winning percentage. So this is basically just how those teams were expected to do versus their difference. So it's a similar range, but you'll see that there's some 50s and 60s that are more skewed left. So I hope that shined light on kind of what the MLB 2019 season had in store for betting data. Basically, we conclude that Vegas knows what they're doing. They had a high correlation between what actually happened and what was expected to happen. However, there's a big cluster of teams that were expected to do really poor, that overperformed. And there's a large cluster of teams that did really well, or were expected to do really well, but performed not poorly, but less than expected. For example, there's teams that are expecting on their 70% range to win, but only made it to the mid 60s, the upper 60s. So I hope that shed some light on that, and thank you very much.